Okay, today we're going to talk about exponential functions and we're going to graph, and they're either going to be exponential growth or exponential decay. So this will be exponential growth because from left to right it's increasing or growing. This will be exponential decay because from left to right it is decreasing. So back to number one, an exponential function is a function where x is the exponent. So the example would be something like d, where x is the exponent. So when you graph these, the first thing you want to do is see if you can move left, right, up, or down, which I cannot do that. I don't have any extra numbers being added or subtracted. So what I'm going to do now is I'm going to make a table. Since x is the exponent, that's where I'm going to put my numbers in the x column. And I'm going to pick nice numbers to work with, because I'm going to pick 1, 0, and -1. So 2 to the first power is 2. 2 to the 0 power is 1. And 2 to the negative first power is 1/2. So next to 1 is the base. Next to 0 is always 1. Next to -1 is always the reciprocal of the base. So now I'm going to graph these. However, before I graph, I have to draw in an asymptote. That is a line that your graph cannot cross or touch. So since x is the exponent, I cannot cross this x-axis. So I'm going to plot these points. So over 1 up 2, 0, 1, -1 up 1/2. And I cannot cross this line or touch it. So that's number 3. Okay, number 4, again, I'm going to use 1, 0, -1. Next to number 1 is the base. Next to 0 is 1. And then next to -1 is the reciprocal of the base. X is the exponent, so I cannot cross the x-axis. And I'm going to plot these points. And then I'm going to connect. So this one's exponential growth, and this one is exponential decay. Okay, so moving on, I'm going to cross off number 5, and I'm going to cross off number 7 and number 6. So that leaves us with 8, 9, and 10 on this page. Okay, so first I need to move my origin. So I'm going to go to the left 3 and then down 1. So if you have a number with x, you always do the opposite. So to the left 3, down 1. That's my new origin. Now I'm going to make a table. I'm going to put 1, 0, -1 in for x. And these numbers are not here anymore because I moved them. So I have y equals 2 to the x. So next to 1 is the base, next to 0 is 1, next to -1 is the reciprocal of the base. Okay, I cannot cross the new x-axis, so it's down here. And now I'm going to plot those points. So this is what number 8 should look like. Okay, moving on to number 9. So we're going to first of all move our origins. We're going to go to the right 1, up 3. That is our new origin. Okay, make a table next. I'm still going to use 1, 0, -1. I don't need these numbers anymore because I moved my axis. So next to 1 is going to be the base. Next to 0 is 1, and next to -1 is the reciprocal of the base. Okay, I got to draw in my horizontal line. I can't cross the new x-axis, which is up here. And I'm going to plot those points. And it's going to look something like that. So it's either going to be growth or decay. Now 10, I have a negative in my problem. I'm not going to move left, right, up, or down, but I'm still going to make a table. I'm going to ignore that negative until after I make the table. So again, I'm going to use 1, 0, -1, the base is 3, that's always 1, and then next to -1 is the reciprocal of the base. Draw in the x-axis there, and this time I have a negative. So since the negative is right in front of the x is changed to their opposite. That becomes a -1, that becomes a +1. So I'm going to plot those points from my new origin, which actually is right there, didn't even move. So -1 up 3, 0, 1, and over 1 up a little bit. And that is my graph. Now you might think this one would be growth because my base is bigger than 1, but it's actually decay because the negative made it flip. Okay, so now we're going to talk about a new number, which is called e. Okay, so just like pi, e is irrational. That means it keeps on going forever and it doesn't repeat. So it's non-terminating and non-repeating. Okay, so E, some guy named Euler, not that that's important, he came up with E to be about 2.718. There's actually an E button on your calculator. I'm going to show you where that is. If you look on the left-hand side, right here where it says ln, right above it, it says E, and then it has an exponent. So if you do second ln, E pops up there. And if I put -1, it's about 3.67. So I'm going to put that right here. Okay, so now we're going to graph where our base is E. Now the reason we're talking about E is because when we get onto this chapter, we're going to be talking about logs or natural logs, which involves the number E. But we're not doing that today. Okay, let's go ahead and cross off 16 and 17. And then on 19, this should be a positive sign, now that I see that. Okay, and I'm going to change 15 as well. I'm going to make this be a negative out in front. Let me just rewrite it. Okay, 15 should look like that. Okay, so again, x is the exponent. First I have to see if I can move my origin, which I can't. 1, 0, -1 goes in the x column. Okay, up here. So e to the first is 2.718. Next to 0 is always 1, and then e to the negative first is 0.367. So for all of these problems on this page, e is the base. So you're always going to use this table. Okay, I still can't cross the x-axis, but now I'm going to plot those points. So I have exponential growth. Okay, 15. I can't move my x or my y-axis. I don't have to go up, down, left, or right. Now I am going to use the exact same table as 14, but the reason I'm writing it down again is because I have a negative. This time the negative is not with the x. So the x's don't change, but the y's do. So I'm going to change all these to negative. Okay, I got to draw this in here, and then I cannot cross that line. So over 1 down to 0.718, 0, -1, -1 down a little bit. That's what number 15 should look like. It flipped it upside down. Okay, 18. So it looks like on this one I have to move my origin first. So I'm going to go, that's a +1. So I'm going to do the opposite. I'm going to go to the left 1 and then down 4. Okay, right there is the new origin. Okay, and since E is the base, I don't need these numbers anymore. Since E is the base, I'm going to use the exact same table that I used back on 14. I don't have any negatives, so I'm going to use that exact same table because my base is E still. The only difference is that I moved my origin. So my origin's down here now. So I'm going to plot the points from the table that I have on 14. And connect. We have exponential growth. Okay, 19. So I'm going to move my origin. Again, I made that a positive x. So I'm going to do the opposite. I'm going to go to the right 3, up 2. Okay, these numbers are now gone. And I have e to the x again. So I'm going to use the same table that I used on 14. But before I plot those points, I have to draw in my new x-axis. And now I'm going to plot those points. Okay, and again, the reason I'm using the same table is because they all have a base of e. This is the table that you use when your base is e. Okay, I think that's it for 5-1. It is.